Earth's magnetic field has always protected us from radiation, solar storms, and the chaos of space. But what if it suddenly reversed? It's happened before dozens of times in Earth's history, and it's starting to show signs it could happen again. Scientists think we might be heading toward another magnetic flip, and it's already begun. For centuries, Earth's magnetic field has been slowly weakening. In the South Atlantic, a strange patch of low magnetism, known as the South Atlantic Anomaly, is growing larger every year. Here, satellites glitch, and cosmic particles break through the magnetic shield more easily than anywhere else on the planet. But this isn't just a local problem. Measurements from observatories and satellites show that the entire magnetic field has been declining for nearly 2,000 years, and the rate of that decline has sped up in the last century. In some regions, the field is weakening by as much as 10% each decade. Scientists think the reason lies deep below our feet. Earth's magnetic field comes from its core, a swirling ocean of molten iron nearly 3,000 kilometers beneath the surface. That fluid motion acts like a giant dynamo, generating electric currents that create the magnetic field around the planet. But that motion isn't stable. As the core cools unevenly, parts of it begin to flow in different directions. When enough of those currents shift, the field above them starts to twist and weaken. And that's what might be happening right now. Satellite data has shown magnetic poles forming in unexpected places, in random spots across the globe. The North Magnetic Pole itself is moving faster than ever before, racing across the Arctic at over 50 kilometers per year. All of this points to one thing. The field is changing, just like it did in the centuries before the last major reversal. We may not notice it on the surface, but the magnetic map of Earth is being redrawn beneath us. We know this isn't the first time Earth's magnetic field has acted this way. When geologists study ancient volcanic rocks, they find something strange buried inside them. Tiny magnetic crystals frozen in place, like compass needles. Each one records the direction of the planet's magnetic field at the moment the lava cooled. And those records don't line up. Some point north, others point south. Layer by layer, they reveal that Earth's field has flipped hundreds of times, sometimes staying stable for millions of years, and sometimes reversing after just a few thousand. The last full reversal happened about 780,000 years ago, but shorter disturbances have occurred since then. During one of those, around 42,000 years ago, the field nearly collapsed altogether. For many years, Earth's magnetic strength dropped to a fraction of what it is today, and radiation flooded through the upper atmosphere. Now, scientists have tried to predict when this next reversal could happen, but there's no exact countdown. The last full flip took place about 780,000 years ago, and smaller magnetic disruptions have happened roughly every few 100,000 years since, which basically means we're overdue, but overdue could still mean thousands of years away. The magnetic field reversal is not something that would happen overnight. When it reverses, it takes time, centuries, sometimes longer. During that transition, the field becomes tangled and unstable. New poles appear in strange places. If the trend we're seeing continues, the field could drop to a fraction of its strength. And that's when space itself starts to matter. Without a strong magnetic shield, the solar wind would reach deeper into our atmosphere. Satellites would face higher radiation levels, communication networks could glitch, and even power grids could feel the strain. The auroras we see near the poles would expand across the planet, glowing above places that have never seen them before. But what if the reversal happened today? It wouldn't be an apocalypse, though it would be chaos for technology. GPS systems would drift and recalibrate constantly. Airlines would have to reroute flights near the poles, where radiation exposure would spike. Even animal species that migrate using Earth's magnetic field might become disoriented for generations until they adapted. Through it all, the planet itself would stay fine. It's just our infrastructure and our dependence on magnetism that would be tested most. If we go back to the last time Earth's magnetic field flipped, it didn't cause mass extinctions or firestorms, but it did leave its mark. When scientists study ancient lava flows, they find magnetic minerals frozen in the direction of the field at the moment they cooled. They reveal how chaotic the reversal was. That period may have lasted thousands of years, long enough for radiation levels at the surface to rise. Today, scientists are watching every sign of change. Satellites like ESA's SWARM mission are mapping the magnetic field in real time, tracking how fast it's shifting and where it's weakening the most. Ground observatories monitor how those changes ripple through the atmosphere, while computer models simulate what the next few centuries could look like if the trend continues. And though no one can predict exactly when the flip will happen, the data is clear. The process has already begun. There's really no way to stop it, since this isn't something caused by humanity or technology, but a deep planetary cycle driven by the movement of molten iron nearly 3,000 kilometers beneath our feet. We can't restart the core or steer the flow. What we can do is watch it happen and try to understand what Earth looks like when its magnetic shield begins to change again.
What makes this so fascinating, in a way, is that we're watching something planets have always done.
On Mars, the magnetic field shut down billions of years ago, leaving it exposed to radiation and slowly stripping its atmosphere away. On Jupiter and Saturn, magnetic fields twist and pulse with the movement of metallic hydrogen deep inside. Even Mercury's faint field flickers as the solar wind pushes against it.
Earth's field is stronger, more complex, and for now, it still shields everything that breathes and orbits above us.
But the signs of change remind us that our planet is alive in more ways than one.